Okay, so in this video we're going to quickly describe acid-base neutralization reactions. They're another form of a double replacement reaction. But in this case, your acid is composed of an anion bonded to hydrogen ions. So I've got two hydrogen ions and a sulfate ion to make sulfuric acid, and then I've got potassium ions and a hydroxide ion here. So it's going to be the hydrogens and the hydroxides are going to produce water. And I'm going to write water HOH, which isn't standard, but it helps with balancing. So those two things go together. And then I get potassium sulfate. And this is called a salt. Any ionic compound can be referred to as a salt. And acid-base neutralizations typically have an acid and a base and make a salt and water. So I've got two hydrogens. I have one sulfate. I have one potassium and one hydroxide. My potassiums are 1 on the products and sulfates are 1. Potassiums are 2, sulfate are 1. My hydrogen is 1 and my hydroxide is 1. So separating these makes it easier because I have a hydroxide here and a hydrogen here. You can see I've got two hydrogens, so I'm going to need to have a coefficient of 2 for my waters. That gives me my two hydrogens, but it also means I have two hydroxides. I can balance my hydroxide by putting a 2 here. That makes it 2 potassiums and 2 hydroxides. And I already have 2 potassiums. Potassiums are the same, hydroxides are the same, hydrogens are the same, and sulfates are the same. So they balance out that way. You have to recall your acid naming rules, which are included here. So if I had hydrochloric acid, it would be HClAQ. If I reacted it with a base like sodium hydroxide, it's going to make NaCl. So that's the positive and this negative, and then HOH or my water here. And then balancing. This is actually already balanced. But acid-base neutralizations are just a double replacement reaction, but they produce an ionic salt and water.